Hi everybody. Here's a quick tutorial on how you could graph quadratic equations. Today, in today's lesson, I would like to touch on particularly the standard form and the vertex form of a quadratic equation. Um, Now, there has been a lot of discussions about what is the quickest way to sketch a quadratic graph. Um, is there something where I could do it with minimum fuss? Um, I actually do think that it really depends on the equation that's being given to you, and that's why I would like to spend a bit of time to show you how you could find the best way for you to graph or to sketch a quadratic graph. Now, today I'm going to spend a bit of time to talk about the standard form and the vertex form. So let's really start on something where I'm going to start off with the vertex form first, okay? Now, in a quadratic graph, it can be used in different forms. So we could have the vertex form, the standard form, or even the factorized form. Now, the vertex form for a quadratic graph looks something like this, which is y equal to a bracket x minus h squared plus k. Now, this looks very intimidating because we're looking at three different parameters. We have a, h, and k. Now, so before we actually proceed on how we could change this equation into the vertex form, I would like to show you a little illustration with using the Desmos first, okay? So let's go into Desmos, and I just created this. I just put up the vertex form onto Desmos, okay? And I want to show you like what these parameters actually do to your diagrams, okay? So we're going to have a quick look at this. So we do have a graph here. So what I did was I keep a, h, and k to be 1 so that it creates the original form of the vertex form. And what I would like to do is I'm going to show you like if I change these values or these parameters, like how does it affect the shape of the graph, or maybe how does it change the movement of the graph, and let's see if you can find any observations from there. Now we know that if I were to now we do know that at the bottom of the graph, we know at this point, this is actually the vertex, which is basically 1 1. Okay, now what I want to do is I'm going to change some of these values, and let's see what really happens to the vertex. Now I'm going to change this h to a 2. Okay, now it seems like when I change this number, the graph actually moves as well. It seems like as the number gets bigger than 1, it moves towards the right. So we started off with 1, then if I move it to like 2, the graph seems to move a little to the right, isn't it? And let's look at what really happens when I change the value of k, because if you look at this point here, the vertex is actually 2 1. So which means that if my h is 2, it seems to coincide with the x coordinate of the vertex, while the k value, which is 1, seems to coincide with the y coordinate of the vertex, which is essentially the lowest point on the graph. Okay, so when I say the vertex, it basically means that it could be the minimum point or it could be the maximum point, right? Depending on the shape of the parabola in a way. Now look at that. If I change this k value to a 2, and it seems that my graph has gone up. And look at what happened to the vertex as well. It became 2 2. So it seems like h and k does indeed indicate the coordinates of the vertex or the turning point, or what we call the minimum point of this graph. And if you look at a, I have not really kind of like moved the parameter, which is a, but I want you to have a quick look at what really happens when I change the value of a. Do you realize that as a increases, the graph tends to get narrower, isn't it? It's like it's being squeezed or being sandwiched in a way, so it kind of gets like really close to one another. Of course, I could increase a to a bigger number if I change this to like a 100. Sorry, let me just change this again. If I change it to 100, I'm sure the graph is going to even get narrower in this case as compared to the original one. Okay, but you see the point, you see what this is really asking for. So you do know that A, H, and K do play their part in changing how the graph is being moved. And in this case, what I'm really more concerned about is the vertex of the graph. Okay, now, so having said this, I'm going to go back to where we started in this little presentation about vertex form. So we do know that vertex form is it could be written in this form, which is a multiplied by x minus h squared with the brackets and plus k. So we know that, as I showed you on Desmos earlier, that h is indeed the x coordinate of the vertex, and k would be simply the y coordinate of the vertex. Okay, now you might ask now, so how does this really apply to the original equation that has been given to us? Now, this equation obviously doesn't look like it's in vertex form, so we do have to change or manipulate this equation so that it does look like the vertex form. Now, in order for us to convert this original equation into the vertex form, we do have to apply the use of what we call a little technique called completing the square. Okay, now of course this can be done in a separate video. If you really want to know how to complete the square, just please let me know and I'll just do another separate video on how to complete the square. Okay, now, but in this particular question, when we have 2x squared plus 8x plus 1, what we want to ensure is that the coefficient of x squared needs to always, when we complete the square, we are always so accustomed to completing the square when the coefficient of x squared is 1. So what I really want to do now is I'm just going to factorize the first two terms first. Okay, so it's going to look something like that. So it's x squared plus 4x, close the bracket, and I'll put plus 1. Now this looks great because now the coefficient of x squared has turned into 1. And so now what I'm going to do now is I'm going to start completing the square right here with x squared plus 4x. So I'll put the 2 here, and what I'll do is I'm going to put another brackets for this, and because there are several users, there are many terms here, so I think I'm going to use a separate bracket for this. Then I'm going to complete the square of x squared plus 4x, so I'll put an x here, and I'll plus, and I'll take half the coefficient of 4x, which is half the coefficient of 4 in this case. I'm going to take this to be a 2. I'm going to square it, and I'm going to subtract this number, which I just half the coefficient of x, which is 4, and I'm going to take this number and I'm going to square it. Okay, and what I'll do is I'll close the bracket and I'll put a plus 1 right here. Okay, so like I said, if you need me to do completing the square, I'll do it in a separate video. Now, what this basically means is that this is written in another form, but which is essentially x squared plus 4x. Okay, so I'm just going to simplify this expression. I'm going to expand and simplify. So what I'm going to do is I'm going to take 2 multiplied by this. So I'm going to get 2 multiplied by x plus 2 squared. Then what I'm going to do next is I'm going to take 2 multiplied by 2 squared. Okay, so that's going to give me 8. All right, because 2 squared is 4, then 2 times 4 is basically 8. So, and I'll do this to be plus 1. So I'm going to simplify my expression, and I'm going to get something like this. I hope this somewhat makes a bit of sense to you. Okay, so what we're going to do next is we're going to start looking at finding the vertex from the vertex form, because we have obviously converted this into the vertex form. And where can we find the vertex? The vertex is basically this number and this number. But we got a bit of an issue here. Now, I'm going to show you, again with Desmos, I'm going to type in this function onto Desmos, and I want you to observe something about the vertex. Okay, so it's 2 bracket. Okay, I'm just going to remember this one, and what I'll do is I'll put this on Desmos. So I'm going to type in this function, which is y equal to 2 bracket, oops, looks like I forgot of 2x plus 2 squared minus 7. Okay, 2x plus 2 minus squared minus 7. So this will be x plus 2 square, and I'll put a minus 7. Okay, I'm going to turn off this. Right, and I want you to look at this little graph here. Okay, and I want you to look at this function that we just came up with, which is 2x plus 2 squared minus 7. Now I want you to look at this vertex here, which is -2, -7. Now, you probably would have realized as well, if you look at the equation, the y-coordinate of the vertex is -7, which is basically the -7 given in the vertex form equation. But I want you to look at what really happens to the x-coordinate of the vertex. Now, because in the equation, it says x plus 2. So the assumption that I first probably would think, just like anyone else, is that the x-coordinate of the vertex should be +2. But if you look at the graph, the vertex basically shows that it is indeed -2. And it seems like the sign of the x-coordinate of the vertex is the opposite of what is written in the vertex form. Okay, so going back to this, when we found the vertex to be -2, -7, one thing I want you to point out is because when we rewrite this, this can be written as 2 bracket x minus 2. Okay, because this essentially is just x plus 2. What I'm really interested in is basically this little point here, which is the -2. And why do we have to do that is because if we go back to the vertex form, the vertex form states that the equation has to be a minus here, which is x minus h, rather than x plus h. So the reason for that is why we have to convert x plus 2 to this, so that this looks like the original vertex form. But as a rule of thumb, what you could do as well is that if you want to save the trouble to find the x-coordinate of the vertex, it's always going to be the opposite sign of the equation that you have. Okay, so if this is a plus, then your vertex for the x-coordinate will be a negative number. So that's just one way for you to remember the vertex, finding the vertex of a quadratic graph if you have the vertex form. So generally this will help you to plot where the vertex is in this case. Okay, now having said this, I want you to show you how we could find the vertex when you're given the standard form. Okay, now the standard form generally would be the original equation that has been given to you. So in this case, we have y equal to 2x squared plus 8x plus 1. This is what we call the standard form. That's the original equation that we have. Now, what I really want to show you is that how this could be done without actually using the vertex form. Now, what I really want to introduce to you is like when we draw this graph, we need to understand what are some of the parameters that we need to look at before we start sketching a graph. Now, so before we come down to finding the vertex from a standard form, I just want to highlight a couple of things. Now, again, I'm going to use Desmos, and I want to show you something, okay? Just to convince you that, you know, this actually makes a lot of sense. Now, so what I'm going to do is I'm going to delete this vertex form. What I'm going to also do is I'm going to open up this graph. Okay, so this is actually the standard form of the graph. What I did was I make A to be 1, B to be 1, and C to be 1 in this case. Now, what I also have done is I've created a line, which is the green line if you look at this. And you realize that this green line actually cuts the graph right across, right through the middle of this quadratic graph, and you realize that it kind of creates like a little symmetry between the two parts of the graph. So obviously the green line is going to be a line of symmetry that passes right through the minimum point of this parabola. So generally what I need to show you now is, and obviously you may have seen that the formula that I wrote on Desmos was x equal to minus b over 2a. Again, I'm going to leave this to another video on how the axis of symmetry is being derived. This actually came from completing the square, okay? But again, the purpose of this video is to show you the difference between the standard form and the vertex form, and how you can actually really sketch a graph at the same time. Now, but before we do that, I'll take away the axis of symmetry. I'm going to show you what happens when I change the a value from the standard form, which is ax squared, and look at what happens when the a changes. You realize that when I increase a to a larger number, it kind of got squeezed, isn't it? It tends to get a bit narrower. Now I want you to look at what really happens when a starts to get smaller. It starts to open up, isn't it? It gets wider. But I want you to take a good look at what happens when it's a negative number. The graph actually changed the shape. It actually turns from an N shape, no, I mean a U shape, to like an N shape. Now I'm going to talk about the terminology shortly. And again, if I were to make it smaller, the graph get narrow as well. Okay? So you kind of see the point when a becomes a negative number, the graph actually changes the shape of it. And when it's positive, then it changes to the shape, which is like a little N shape or a little smiley face that you could see in this case. Now, so let's get back to some terminology that we need to take note of. Is that we know that the graph is going to look something like that. Okay? Reason for this is because the coefficient of x squared is positive. Okay? So we know the graph is going to look something like that. But it's also important for us to find out where the vertex is. Now, of course, we know that the vertex is going to be at this point. But I want to show you like that we can actually find the vertex using a different way. Okay? Now, we do know that earlier when I created the line of symmetry, the equation that was given to us was something like that, which is x equal to minus b over 2a. Now, this line is what we call the axis of symmetry, which is basically the line that cuts right through the middle of the graph. Okay, so this is what we call the axis of symmetry. Now, just like how you did with the quadratic formula, we know that a is just the coefficient of x squared, which is basically 2, and b is basically the coefficient of x, that's going to be 8. Okay, which comes from this number as well as this number here. And if I put this number into the formula, I'm going to get something like this, which is negative 8 divided by 2 times 2. So I'm going to get negative 8 divided by 4, which gives me negative 2. And that literally gives me, all right, the x coordinate of the vertex. So let's go back to the graph again. I'm going to put this in. And we know that the minimum part of the graph is somewhere okay, let me just zoom in a little more. You know, the minimum point is going to be somewhere here. Okay, but I have to obviously change my a value and my b value first. So I'm going to take all this away first because this creates a lot of confusion. A would be, in this case, I'm going to delete this first. I'm going to change it to 2. B would be 8. And C would be 1. So that gives me the original equation. Okay? So this was the graph that I was looking at. And I want you to look at the vertex here. You realize the vertex for the x coordinate is negative 2. And didn't we just found the same thing here? To be -2. Because if you look at the graph again, this green line actually cuts this graph right at the minimum point. Okay, so this equation, which is x equal to -2, kind of coincides with the it does goes through the x coordinate of the vertex. Okay, and that really leaves us to find out what is the y coordinate. So we're kind of missing the y. So if we found the x, we can easily find the y value by substituting this number into the original equation. And by doing that, and working out this number, is going to give me -7. So which means -2, -7 is the vertex of this graph. And of course, if I were to sketch this graph without using any graph paper, this is y and this is x. Of course, I know my vertex is of course -2, -7. So since it's a rough sketch, it'll be somewhere about here. Okay, and simply if I erase this, just to do a quick sketch of this, the graph is going to look something like that. Okay, because since we know that this is going to look like this, so the graph is going to look something like that. Okay, now of course we could be more accurate with how the graph is actually being drawn, because all we really know is just the vertex. If we could find out more points in the graph, then we should be able to identify how the graph is going to look like with more accuracy as well, because in this case I only have the vertex. So that's why when we do a sketching of a graph, we need to see what other points we could actually derive from the equation itself. Now this is obviously a long process, but again, this video is really out to show you what's the difference between the standard form and the vertex. Okay, I will show you a little more on how we could sketch a quadratic graph in another video, but I hope this video shows you the difference between the standard form and the vertex form in deriving how you could find the vertex. Now, is there a better way? I would say it's really up to your preference. If you think that you can complete the square comfortably, then maybe changing it to a vertex form might be easier, because you can actually literally see the vertex just by looking at the equation itself. Now if you haven't, so just like the vertex, right, if you complete the square well, you can actually see these numbers as your vertex. But if you have the standard form, then you do have to use the axis of symmetry, which basically allows you to find the x coordinate of the vertex. If you could remember this formula, or if you could use this effectively, then I think this might actually be easier for you to find the vertex, because completing the square can actually be quite challenging at times. So again, find a way that you think would make you feel the most comfortable when it comes to finding the vertex in a quadratic graph. Okay, then obviously we'll talk about the sketching another time round. Now, and I hope this video helps to distinguish the difference, or to distinguish between the standard form as well as the vertex form. All right, more videos to come. Please make sure you subscribe to the channel, like this video. Next video, I'm looking at how we could sketch a quadratic graph, and I'll show you all the steps needed for you to succeed in sketching these kind of graphs. All right, till then, I'll see you the next time round.